Good morning, everyone. This is your teacher, MsRita. Today, I will be explaining to you separation techniques of homogeneous mixtures. We're gonna do a quick revision of what we already learned and continue the explanation. We have two types of homogeneous mixtures. And I remind you, homogeneous mixture means that we can only see one phase. These two types are solid-liquid, like salty water, and liquid-liquid, like alcohol and water, or acetone and water. In order to separate homogeneous mixtures, we can use three techniques. The first one is chromatography, that we already explained and we're gonna review it. Simple and fractional distillation that we're gonna explain today, and crystallization. Let's do a quick revision about chromatography. So we said that this is a technique that we use in order to decide if a color is a pure substance or a mixture. To do so, first we have to draw a line on the filter paper using a pencil. On the line, we drop the dye that we want to check if it's a mixture or a pure substance. After a while, the colors will start to move up on the filter paper. If you look at the picture you have in front of you, you can see that we have a purple dye on the filter paper. After a while, the purple dye will start to separate into two components or two colors, which are red and blue. If you look at step 3, you can see that blue separated higher than the red color. From this picture, we can conclude that the purple color is a mixture of two colors which are red and blue, and these colors would separate into different heights because they are different substances. Now you're gonna ask me, why these two colors separated into different layers and different heights? The reason why this happens is because some colors dissolve easier in water than other colors. In this case, the blue color dissolves more in water than the red color, which means that the blue color will be able to move higher up on the filter paper than the red. Now please, I need you to open your books to page 97, question 4. Before the mid-year, you had this number as a homework, but we didn't get the chance to correct it, so let's do the correction together. In part A, they are asking you to name the technique you are seeing. So on your books, you can see that this technique is chromatography, and they are trying to separate a green dye to check if it's a pure substance or a mixture. In part B, they are asking you to draw how you think the green color would separate on the filter paper. In front of you on the slideshow, I'm showing you that the green color will separate into two colors, yellow and blue. Knowing that the blue will move higher on the filter paper than the yellow because it dissolves more, which means it will be easier for this color to move higher than the yellow one. In part C, they are asking us to deduce if the green color is a mixture or a pure substance. So from the previous part, we can know that since the green color separated into two dyes at different heights, which are blue and yellow, this means that it's a mixture and not a pure substance. In part D, they are asking you to explain why we use pencil to draw the line and not ink. The answer is simple. It's because pencil does not dissolve in water. So when the water moves high on the filter paper, the pencil will not move with it. However, if we use ink, ink dissolves in water and it will move up on the filter paper and give us false results. So please, I need you to copy these answers on your copybooks. Now we're gonna explain a new technique to separate homogeneous mixture. This technique is called simple distillation. It is used to separate a solid liquid homogeneous mixture such as salty water. It can be used to separate liquid-liquid homogeneous mixtures such as acetone and water, but with the condition that the liquids should have at least a difference of 50 degrees Celsius in their boiling points. And I remind you that different substances have different boiling points. If not, then it's better to use a different technique which is called fractional distillation. To understand more how this method works, we can look at the picture in front of us. This technique is made from different parts. We need a Bunsen burner to act as a heater, we need a stand, a flask where we're gonna put our mixture, for example salty water, we need a condenser, and an Erlenmeyer. First, this technique is based on two physical changes, evaporation and condensation. So the Bunsen burner heats the flask. When the flask is heated, the water will evaporate and turn into water vapor. Then the water vapor will move and go into the condenser. On the level of the condenser, cold water is circulating around it, which means that the water vapor will cool, it will lose energy and transform into liquid again. Then the liquid will drop all the way down to reach the Erlenmeyer. So now in the Erlenmeyer we will have the distillate, which is pure water, and in the flask we will have salt, which we will call the residue. And this way we would have separated our mixture into pure water and salt. One important question that we need to ask ourselves is, why does water in the condenser flow from bottom to top? As you can see in the picture in front of you, the water enters from the bottom and leaves from the top. The reason why this happens is because when we allow water to enter from the bottom, we're giving it more time to fill the whole condenser, the whole space of the condenser, before it can get out, which means that this will give us more efficient cooling and better results. So this is everything for today. Please, I need you to prepare as homework page 95-96, number 2, parts 1, 2, 3, and part 4 only from A to F.